Hello everyone, here's Paolo and welcome to the second tutorial about the 737 next generation, in this case with the iFly Boeing business jet. We are parked again at Montevideo International Airport, that is Carrasco International Airport. Sierra Uniform, Mike Uniform is the ICAO code for the airport. Actually today we will talk about this place. There are 6 of them on the 737 and how the information are presented and how were they draw inside those 6 displays. Actually, so we will talk about flight instruments and indications on the 737 next generation. Actually, the systems that the 737 presents are actually very common in all other airliners. There are some differences here and there, but the general information are actually the same for every airliner, almost. I will go also a little bit in deep with how the information are taken from the outside, how they are calculated inside the systems, and how they are presented to the pilots inside the cockpit. Actually, as I said, we are parked here, and now I think we can go inside, start up at least the EPU and the battery to get the screens to come up with us. I will just start up the electrical system and then go ahead with our overview about the display. Okay, here we are. We are inside the cockpit and we are in cold and dark situation. And as you can see now, we are watching at the 6th display units installed in our 737. Actually, as I said, there are 6 screens. Each of these screens is called a display unit, or DU. As an acronym. Those displays are actually commanded by a single system that is called Common Display System. This Common Display System, or CDS, is composed by 2 subsystems. Those 2 subsystems are called display electronic units. There is one, actually the acronym for them is DEU. There is a DU1 and a DU2, so there are 2 of them. The first one controls the 2 pilot screens, so the pilot screens, and the upper display unit, while the second display electronic unit controls the 2 first officers' screens and the lower display unit. Actually, those 2 units can talk one to each other. There is a way to select only one of those 2 units to print the data on the screens in case one of the 2 is faulty, and they actually takes information from a bigger system that I will talk later about it, and they also only calculate and present the data on the screens. As said, we have 2 of them. They actually are controlled by different switches in the cockpit that we will see later. We have actually the ability to select one or the other for printing information on our screens, and actually they must give the same information from the first to the second DU. So actually the aircraft cross-check the informations between DU1 and DU2, and if there is a disagreement about the informations or the value of things that are presented to us, the aircraft actually tells us printing a number indication on the screens. Those 6 screens actually have a name. For each pilot we have one PFD, or primary flight display, one navigation display that is also present on the first officer part of the cockpit. Then we have an engine display that is actually the upper DU, and we have a lower DU that can be used for secondary engine indications or systems informations about flight controls, brakes, and actually hydraulic system. Those 6 screens actually are off and are presented, they present actually the data that is calculated by aircraft systems or equipment. Actually, the data coming from for these screens is actually collected by a system that is called Air Data Inertial Reference System, or ADIRUs, and this system is composed by different equipment. Actually, we have 2 units called Air Data Inertial Reference Units, or ADIRU. We have ADIRU left and ADIRU right, or 1 or 2. Actually, the left ADIRU gives data to the left DU, so for the pilot's information, and the second ADIRU unit gives the data to the DU2, or the first officer DU. Actually, the data taken from those systems is actually clearly various. We have actually the ability to have an inertial reference unit into the ADIRU that are composed by gyroscopes and accelerometers. Actually, all these platforms can calculate speed, acceleration in every 3D direction, and actually they can calculate also the position of the aircraft, the speed of the aircraft, and the direction and the wind speed. About the speed of the aircraft, we have the ability to calculate the speed of the aircraft and other important parameters by using the pitot tubes and the static ports. We have a total number of 6 static ports and 3 pitot tubes. Actually, we have 1 pitot tube for the pilot or the captain, 1 pitot tube for the co-pilot, and 1 standby pitot tube. The same goes for the static ports. We have 2 of them for the captain, 2 of them for the first officer, and 2 of them for backup. Actually, the captain equipment is connected to the ADIRU number 1, so to the left ADIRU, while the captain equipment is connected to the right ADIRU. Say that the information that actually the ADIRU and the DU units manage are actually electronic, while the information that are given by the pitot tube and the static ports are pressure. So there are 4 ADM, or air data monitors, that actually take the pressure from the pitot tubes and the static ports and transform it into an electrical signal. The electrical signal is later transmitted to the ADIRU to be worked on, to be sent to the DU units, and to be collected for the screen display on the aircraft. The static ports and the pitot tube for backup actually are not controlled by any ADIRU unit. They are directly connected to the standby instrument. Actually, we have a magnetic RMI that is analogic, and the digital ISFD, or integrated standby flight data instrument, that actually gives us the speed, the altitude, and the attitude of the aircraft in case of a failure of the other systems. The screens actually works on AC power. They can be powered by DC power, by the standby power on board the aircraft. Actually, I will not go inside the electrical system today, so I will not give you any details about how they are connected to the system. Just remember that there is the possibility to check all the screens using only DC power, so power coming from the batteries, while the ISFD and the standby power and the standby instrument power is actually DC power, the hot battery bus, and so it can be powered only by the batteries. Actually, remember that the ISFD magnetic indications about the heating are given by the left inertial reference system, so you need to align the left IRS before using magnetic heating into the ISFD. Say that, I think we can start up the aircraft, start up the screens, and so I will be back soon with the screens on for going on with our tutorial. Actually, as you see, we have just powered up only the battery and the standby power bus, and so we have only DC power available for this moment. In this case, as you can see, there is only the ISFD that is powered up. Now it is going for initialization program, and now it can give us directly the altitude and the speed, because those two information are taken directly by the ports on the fuselage and by the pitot tubes that are actually not connected to any AC system. They are directly connected to the ISFD, so those information can be printed directly into the ISFD. The initialization altitude is needed because inside the ISFD there are gears that actually give us the altitude informations. Those gears are actually needed to start up to initialize with DC power, and so there is a period of around 3 minutes for startup, or in case of the ISFD for first startup, if you are stopped on the parking, the initialization progress is only of about 30 seconds or so. Actually, as you can see, the heading is not displayed here because heading is taken directly from the left IRS that is actually not powered up yet and not aligned up in our aircraft. I now will go to set up the IRS. I will not show you anything about the IRS now because this will be done later in other tutorials. Now just check that the 3 DU1 screens are actually on, because we have powered up the DC and the standby power, standby power switch. The standby power switch actually transforms DC power into AC power for the standby power AC bus, and so those screens are powered by DC power transformed into AC power. Now I will connect the ground power and go for all the screen to give you more information about those screens. Okay, now we are on AC power given by the ground power switch, and as you can see we have only 3 screens on. This is done because actually the right DU unit takes about approximately 1 minute, 2 minutes to start up after initial AC loading. This is actually because of the avionics configuration, but those screens will be get on very soon. As you can see, now the screens does not give us any information about the magnetic heading, about the indication of the altitude, because the IRSs are not aligned. Actually, information on those screens are given by the IRS units, and the IRS units needs an alignment that can go between 5 minutes to 17 minutes based on latitude you are actually. Usually the time to align the IRS is greater when you actually goes on higher latitudes or lower altitude, latitude on the south part of the world. At this point, as you can see now, also the copilot screens are on, and so we have powered up the AC power for those screens. Now I will start up the IRS alignment, and then I will get back to give you some information about the screens when waiting for the alignment to be complete. Okay, we have now just started up the alignment process for the left and right IRSs, and now we will give you some information about the present indication given by the 2 main screens, so the PFD and the navigation display. Actually, as you can see, there are a lot of amber boxes, yellow boxes that are presented on our screen. Those indications actually present information about the failure for the related informations, or actually problems regarding those information. Actually, the boxed information are a failure of the relative channel, while the not boxed yellow indication actually refers to problems with indications. In this case, as you can see, there is a landing altitude indication here and the no V-speeds here indicated. This means that those information are not yet set up in our cockpit, so the PFD will tell us these information are needed before the start of the flight. While the attitude flag here, the vertical speed flag, the heading and the map heading, and the map indication here actually show us that there are a failure about those information. Actually, this is not a real failure, but is just the loss of information because the IRS are not yet aligned. Now I presented you those information. Actually, I expect 7 minutes before the alignment of the systems, so I will start from the two system display here, the upper display and the lower display unit, to give you some insight about this. I will just zoom into this. As you can see here, we have a better presentation. Actually, the upper view can have two main configurations. Actually, this is the standard one, and these present only mainly engine indications, primary engine indication, and actually also category 3 or outland information in case you have an active outland failure system, fail active outland system. Actually, the iFly is not mounted with fail active system, so we have just engine information on this part. We can see that here in the upper part we have the true air temperature indication. Actually, the true air temperature can be seen here because we have an aspirated TAT probe. There is also an option with non-aspirated TAT probe. In case you have not a non-aspirated TAT probe, this indication will be not here now because you need to have pneumatic pressure and so from the EPU or from the engines, and actually you have to set temperature directly into the FMS system to have the TAT indication here. Then we have actually the thrust display. Now it's a takeoff because the FMS is in takeoff configuration. Actually, this indication changes with the phases of flight. Actually, it will go to climb, to cruise, and to go around in case you need to go around. Actually, this indicates the thrust limit that is actually connected to the AAC system. Under this indication, we have the main engine indication. We have one gauge for every engine, so we have two of them for every parameter. We have N1, that is the main rotation of the low pressure compressor inside the engines. Actually, N1 is a percentage, so it goes from 0 to 105%. I think this is actually the maximum. As you can see, we have a green indication of a percentage, now is 98.7%. This indication is the actual thrust limit configured by the FMS. Actually, we have in takeoff limit, and the takeoff limit for the N1 is 98.7%. The same indication is given by this green triangle, and this green triangle actually is positioned at this percentage of N1. This is a rotary gauge. Actually, there is this indicator will rotate at the actual engine and one speed parameter set by the thrust levers, and we have a red limit. This red limit is actually the limit for the engine. Going over this limit is actually a problem. Going over, you need to do checks on the engines before being able to redo a flight. And then we have a yellow line that actually is the maximum continuous thrust that you can take from the airplane at this moment. Under the N1 gauge, we have the EGT, or exhaust gas temperature gauges. These gauges are actually very important because a rise in EGT is actually an indication of some problems inside the engines. EGT actually now are off. We have no indication here. Actually, this is rotary indicators again. Those rotary indication actually can be shown only during only when the engine are started up, and then we have also a yellow line and a red line that means the same things as the N1. So we have a maximum continuous thrust, maximum continuous possible for AGT, and the red limit is the never excess limit for the EGT. The last indication we have here are those two white boxes about the fuel flow. The fuel flow, in this case, we have the airplane configured for metric system, so we have kilograms per hour, actually kilograms per hour of fuel for engine. The fuel flow is actually a very important parameter for fuel consumption and to check how the engine are consuming the fuel, if they are over the predicted figures or under the predicted figures. This completes the engine parameters for this panel. Actually, we have other indicators here about problems. Actually, we have low oil pressure light indicated on in yellow. Those indicate obviously that the oil pressure into the engines are low. Then we have also other two indicators. The center indicators are actually about the engine oil filter bypass. In case the oil filter of the engine are clogged, they are bypassed, so the oil can pass anyway inside the engine to lubricate and to cool down the engine parts. And the first light is about start valve. When you actually start the engines, those lights come up saying start valve open on lights, saying that the start valve is actually open, and the pneumatic pressure coming from the packs are actually routed inside the engines. If you press the first MFD engine switch here, actually the lower DU goes off, and we have a compressed engine information about the upper display. As you can see here, we have indication with only parameters. Actually, these parameters are white. Not everything is displayed here because the engine are off, but actually we have N2 percentage. N2 is actually the rotation on the high pressure compressor shaft into the engines, and is the secondary engine parameter after the N1. Then we have again the fuel flow that is substituted by this indication. We have the oil pressure, the oil temperature indication, the oil quantity, and the vibration. Actually, the oil pressure is given by in PSI, and the oil temperature is given into degree Celsius. Oil quantity in this case is 17, and it means in quarters, and so is particular. Vibration actually calculate the vibration of the engines, and this is another parameter for problems. In case you have something that is broke inside the engine, the vibration will rise very high on the affected engine. This actually complete the engine parameters for this panel, and we have only the fuel quantity indicator. Actually, here we have fuel given in kilograms for the center tank and the two wing tanks. A total figure is displayed here. Actually, this is a digital readout indicators. There is also the possibility to see round deal indicators that actually show the same amount, but with also an indicator of percentage of how much the affected tank is full or empty in percentage. But actually the indicator is the same. Now we can go back to the secondary engine information that are here on the lower DU. The lower DU has two presentation. Actually, this is the first one, and actually it shows secondary engine parameters. We have N2 percentage. I've yet explained it. We have only a red limit indicator here, and a percentage is shown with the digital readout. We have again a fuel flow indication that is actually the same as the fuel flow in the primary engine display. Then we have oil pressure and oil temperature gauge. Also, these gauge are actually the same. We have only a oil pressure must always be over a particular limit, so we have a minimum limit that is red, and the minimum wanted limit that is yellow for oil pressure. And we have also the oil temperature indications. Oil temperature indication have a higher highest limit for the maximum temperature possible, that is yellow, and the max temperature limit that is red and never be excessive. The oil quantity indicator have only a box with its value. Actually, this box turns completely in white when the oil quantity is too low on the respective engine. And then we have a vibration indication. There is no red limit on this indicator. There is only a yellow limit. This yellow limit is actually the maximum tolerable limit for the vibration on the affected engine. Actually, this is all the engine parameters that can be presented on the screens of the 737. If we go to the system switch of the multifunctional display MFD that we have here, we can see the second presentation of the lower display unit. Actually, we have this is the system display and actually show different information. First of all, we have hydraulic system presentation. As you know, the hydraulic systems on board the airplane are two, the A and the B, and then there is the standby, but we have information about the A and the B. We have a quantity in percentage with 99% and 98% in this case, and actually if the quantity is low, a refill indication is actually printed in white at the right of these indications. And then we have the pressure indication that actually now is low. We have 60 psi to the systems because the pumps are on and the engines are off. Sorry, the pumps are off and the engines are off. Then we have the brake temperature indicator. Actually, the brakes are only on the main gear, and we have a display with two digits with a point, floating point into the middle. Actually, those indications show the 100 of degrees Celsius that actually the brakes have. Those indications turns yellow and red in case of high temperatures, but actually with a normal landing, those figures actually go to 100, 110 degrees Celsius maximum for each brakes. For each brake, actually there are 4 of them, one on each wheel. The last part of our panel is actually the flight control position display. Actually, it shows the position of every flight control surface on the 737. We have the elevator position, the rudder position, the 2 flight spoiler position, not actually the ground spoilers, but only the flight spoilers, and the 2 aileron position for the wings. Actually, one very important thing is that actually the U-damper that moves the rudder to check the slip of the aircraft is actually shown here on this display, also being automatic. So if you are flying and you turn the 737 in flight with U-damper on, the U-damper movement will be seen on the rudder with you doing nothing on the rudder itself. This completes our lower view check. I will go back to the secondary engine parameters, and now I will enter the IRS position into our FMS to be able to see the complete PFD and ND on our side. Okay, now we have set the position itself. Just don't see what I'm doing with the FMS. I will do another tutorial about it later, or if you know what I did, very good, you don't need any tutorial anymore. So now, as you can see, we have the primary flight display and the navigation display that are actually on. I can just open the primary flight display here, and I will explain you something and the presentation of the informations here. Actually, we have a pretty simple information about the 737. We have here an attitude indicator with the actually the airplane symbol. We have a scale for degree up and down, the horizon line, and a bank angle indicator. Actually, we have here an indicator. This triangle will turn left or right while turning the airplane, and we indicate the actual bank of the aircraft. We have 10, 20, 30, 45, and 60 indications. And down here we have a rectangle that is actually the side slip indicator for the flight or for the turn. Actually, it's like a Veers bandometer on the on a light aircraft is just this indicator. Then we have here the speed tape, we have an altimeter tape, a vertical speed tape, and a magnetic indication down here. Last thing I will show you is that that is the flight mode annunciator. Actually, it shows the modes that are active or armed into the autopilot system. Actually, it shows thrust indication here, lateral navigation here, and vertical navigation here. So actually roll and pitch modes. Other information about the PFD. Actually, I've set the PFD with all the information I can actually set on this screen. As you can see, now we have the altitude here. This indicator here is actually the radio altimeter that is in digital, and it is on only when under 2,500 feet above ground level to the zero. Now we show zero because we are at the ground. Here we have an angle of attack switch, and it actually shows the angle of attack in degree, and a green band that is okay for approach, and the red band that is actually the limit for the stall. Then we have the speed tape. Actually, the speed tape show the speed in this rectangle here, the actual speed. It show only speeds greater than 45 knots. So before 45 knots, you have to check down here where we have ground speed. Actually, ground speed will go for each velocity you are maintaining at that point. In this case, it's 0 because we are stopped at the gate. Then we have a tape. The tape is provided with 10 knots increments, and as you can see now we have this white indicator that is actually set on 80 knots. That is the takeoff roll check for speed at 80 knots. You can set it also on 100 knots. The same type of indicator is also set for V2 plus 50 knots or 10 knots in based on the options of the aircraft, and actually will be seen while on climb out after the takeoff. The no V-speed indicator actually shows that we have not set the V-speeds, so no V1, no V-rotator, no V2 on this aircraft, and we have later, for the last part, a magenta indicator. This magenta indicator actually shows the commanded speed by the YASMAC window here, so by the knob, or the actual FMS selected speed. Actually, this speed can be passed in Mach. These indicators show the speed, and here up we have the actual speed in digital readout. The same indication are actually present into the altitude tape. Actually, the altitude tape is in hundreds of feet, and we have a window with the actual digital readout altitude of 115 feet now, and actually it can go from minus 1,000 feet to plus 50,000 feet above sea level. We have again an indication of the autopilot commanded altitude. Now is 10,000 feet, a window that is out of scale, so it is positioned here, and actually this is commanded by the altitude knob only, and maintained by the FMS and the autopilot VNAV configuration. We have down here the barometric set. This barometric now is in inches, but we can pass it into hectopascal, and I later will show you how to do that. Last thing, we have a landing altitude indicator here. The landing altitude indicator shows that we have not yet set the landing altitude into the pressurization panel. This can be done automatically by the FMS while selecting an arrival airport, or doing manually by using the pressurization panel. We have now a vertical speed tape. This vertical speed tape actually shows the vertical speed of the aircraft. Over or under the this scale actually will be seen with the actual rate of descent or climb in hundreds of feet. Actually, you will see here, for example, if you're climbing at 1,000 feet per minute, you can see plus 10 up here. We have here the scale the full deviation scale for the ILS. Actually, the ILS is selected here, and as you can see, we have a frequency, a direction, and a DME distance that is not displayed, and elevation indication. In this position here on the top left corner, you will see all the indication about what you are now seeing on the scales. Actually, if you are working with LNAV and VNAV scales, you will see that those scales actually are NPS or navigation performance scales with actual RMP or AMP, and actually they will see here LNAV VNAV. Going down here, we have the heading scale. Here there is the heading scale. The same heading is actually here is set in green. You can see MAG indication. Actually, this is the magnetic heading. In case you could have the ability to check to switch to true north, and so true heading in case you are flying near the North Pole or South Pole, Antarctic or Arctic. The last thing you can see here is actually the heading selection in magenta. We have a digital readout of the actual heading selection and a scale selected here and a selector. This completes our primary flight display indicators on the primary flight display. Now going to the navigation display. While the primary flight display shows the main flight information, main flight parameters for flight command, the navigation display actually shows all the information for navigation, for the route, for the traffic, and for everything else you can actually ask from the display. Actually, we have here a scale about the degree. We have open here the track. You can also select that this can be the heading. We have the track, and this magnetic in the same way there was on the PFD. This is actually the digital readout of the track. We have this line actually show the position, the direction of the airplane. Those ranges actually show the range selected on the EFIS control panel. Now we have a range of 5 nautical miles, and the alpha is 2.5 nautical miles. This triangle is actually the airplane symbol, and we have the heading select indicator that is actually set on 0, as you can see on the heading window. Other thing you can select on this panel, actually we have in map mode. There are other three modes for the navigation display. Actually, the map mode is the most used one, and this is the one you will use in any case. Up here, actually, you will see ground speed, true airspeed in case you are flying, and actually the wind information. This will be wind direction and wind speed, and down here will be presented an arrow with wind over 5 knots in intensity. You will see an arrow pointing where the wind is flowing around the aircraft. Here we have the waypoint indication. Up here we have the waypoint indication. Usually when you have a route loaded up into the FMS, the route is displayed into the map display. Actually there is the next waypoint in magenta here, the estimated time of arrival over the waypoint here in Zulu time, that actually is taken by the clock, and the nautical miles to the actual waypoint displayed here. Down here we have also the FMC source. Actually you can see we have FMC left, because the FMC, the flight management computer left, is actually giving information to the left screen, the left navigation display, while the right one is giving information to the right navigation display. Then we have two navigation radius indication about the VR1 and VR2. You can also select the ADF1 and the ADF2 on those sources. Actually, the VR1 or the ADF1 pointer inside the scale are actually produced by only one line, while the VR2 and the ADF2 pointer are actually composed by 2 lines or bold indicators. We have a TCAS off indicator because the TCAS and the transponder are actually off, and we have also the RMP AMP indicators here. Actually we have required navigation performance of 1 nautical miles and an actual navigation performance of 0.02 nautical miles. Those indicators are actually very important, but we will discuss this later, because we need a complete tutorial about it to be explained good enough. now complete the explanation of the based part of this display. Actually, if we go to the navigation display, as I said, there are other possible display mode. We have a plan mode here. The plan mode actually display the true north, is actually displayed in the true north position. So as you can see now, we have the north indicator with a pointer, green pointer, east, west, and south pointer. Again, we have the FMC, the wind and ground speed, and then actual waypoint indication. Actually, the plan mode is used to check the route inside FMS. You can actually show the route usually, and you can skip to each waypoint on the route to check how the route is displayed by the system, if the arrival route is loaded good, and if everything is set for the route itself. Actually, it is used mainly for control and to check the route, but is not used during flight very much. Then if you go back, we have the VOR and the approach indicator. Actually, those two modes are pretty similar. We will start with the approach mode. The approach mode is actually composed by again a track rose with the same indication of before. The only things that change are actually the glide slope indicator and the localizer course deviation indicator into the middle of the screen. Actually, we have this indicator that is the actual course selected on the course select panel. If you can see, I can change the course here by rotating the knob here, and I can select my ILS course on this panel. Actually, we have also the heading indicator, and up here we have no more the waypoint, the next waypoint indicator, but we have the ILS indications. Actually, we have ILS 1 set in green because it's is actually loaded into the VOR1. We have the frequency of the ILS, the course of the ILS, and the DME distance to the ILS, actually displayed here in case we have an ILS valid frequency loaded inside the airplane. Say that we can go also to the approach in case, sorry, to the VOR mode. The VOR mode actually take out the glide slope is not more needed. We have only the CDI, so the course deviation indicator, but it works actually the same. We have the VOR1 and not the ILS1 indication. We have the name of the VOR usually, the course, and the DME distance. This complete actually our ND display explanation. Actually, now we will talk about the controls of the screens, and later I will show you more indications that are possible to be shown on those panels. Actually, the navigation display can be, in the primary flight display indication can be controlled by two panels that actually are the EFIS panel, or the electrical flight instrument system panel. EFIS control panel are this one and this one for the co-pilot. Actually, my side control the captain screens, while the co-pilot one control the co-pilot screens. We have different information that can be printed into the navigation display, and I will show you. First of all, we have the minimums rotary knob. Actually, these minimums rotary knob can be set in radio or in barrel. Actually, the radio is used only for category 2 and 3 ABC ILSs, while the barrel selection is actually used for all the other approaches, also with category 1 ILS approaches. Using this, we can actually open the PFD. The indication about the minimums are printed into the PFD in this part of the screen. Actually, if I rotate now, it is set into radio position, so it will take information from the radio altitude of the airplane. If I rotate this screen, as you can see, the radio indication is displayed, and I can actually set up my desired radio decision altitude. Sorry, 8 for hour. If you press reset, actually the indication is taken out of the screen. If you select the barrel and then I rotate, actually you can see now it's selected as a barrel reference, and as you can see there is also a green bar displayed into the altitude scale. Actually, this is the same altitude for the barrel, and is displayed into the altitude scale. I can actually move it, as you can see, and I can get over or down 500 feet. That is actually the standard bar. Now I will reset the system. If you go radio, the indicator is always displayed, but is only selected by a triangle, not a triangle with a line. And this is because other information about the decision height will be taken in case of radio. Then we have the flight path vector switch. The flight path vector can be set on. As you can see, it is this circle with these 3 lines. Actually, the flight path vector moves into the altitude indicator, showing the actual direction and trend of the airplane. Actually, it will show in vertical the vertical path of the airplane, and in lateral the lateral drift because of the wind of the airplane. You can set it on or off pressing the button. The meters button actually select on the meter conversion between feet. Over here we have the meters in digital readout, and here we have the meters for the actual selection of the altitude all button. And then we can go off again. Then we have the barometric setting for our airplane. Actually, you can select between inches that are now selected and the Pascal that I'm selecting now, 1013. Actually, rotating the knob select different hectopascal selections. I will get back to 10, and for example, if I go 125 and then I press the button standard, the airplane go to standard. Actually, standard now is in yellow because we have not yet passed the transition altitude that is expected by the FMS. You can select the transition altitude in the FMS, and when you will pass the standard altitude, it will go to the standard yellow. You will press standard button, and actually the standard indication will be in green. Reselecting standard will go back to the normal indication for barometric pressure. Now we will go back to 1013, that is actually my altitude at the airport of 1012, and this is okay. Then we have the controls about the navigation display. The navigation display, we can open it now. We have 2 buttons that control the radio sources for the navigation display. Actually, I can select it off and it removes the indication, or I can select it on the ADF, selecting it into the blue color, getting back to the VOR, and the same is for the second source of indication. Then we have actually the mode selector for the navigation display. Actually, you can select approach, VOR, map mode, and plan mode. Actually, if you press the center button, it will change the mode to draw the information. If I press center, as you can see, now we have a full rose indication. Actually, the indication presented in this case are actually the same as the other modes with a alt scale mode, but actually the center can give you more information about situational awareness also behind the aircraft in case you need them. Pressing again the center switch, as you can see, we are the vertical or VSD vertical situation display. The vertical situation display actually shows the vertical profile of the aircraft. Actually, there is a triangle that is actually the aircraft. We have a trend line that actually is the alpha length of the VSD. Actually, it moves up and down, showing how the airplane is climbing or going down. We have here an altitude scale that is actually the same as the altitude step on the PFD. And then we have the terrain indicator. Actually, the terrain is presented here in with lines and in colors. Actually, the colors are green, yellow, and red. Actually, the green colors show terrain that is lower than 500 feet under you. Yellow show that the terrain that is between minus 500 feet from your altitude to plus 2,000 feet your altitude, while the red indicator shown and that is not displayed here is actually about terrain that is over 2,000 feet higher than the altitude you are at the moment. You can see also that actually the VSD is present 2 dashed blue lines here. Those 2 lines actually show the portion of space that is actually displayed here on the VSD. For example, if we have a waypoint that is located here, the waypoint that is located here, The only waypoint that will be displayed on the VSD is the actual set here in the center, because in case you don't have those information, we have a lot of information displayed on the USD, so it's better to have this ability. Actually, we will go back to the normal view of the navigation display. Then we have a range selector with a traffic button. The traffic button actually selects the traffic indications on or off, and actually turn on the range rings inside the navigation display. While the range selector can select higher ranges for navigational display view, actually is explained by itself. As you can see now, we have gone. You can select anything between 5 and 640 nautical miles. The last thing that it's remaining out of our source, I will select now 40 because I want you to show anything, is where the switches. Those switches actually turn on information about the navigation display. The first switch is about weather radar, and as you can see we have Wixer indication here. We can turn it on and off. Then we have station. Station actually show all available station around the airport. As you can see, I select out and you can see all the indications. We have different indicators about every station. For example, this is only a VOR, while this is a VOR DME station. We have also the navigate's name in 3 letter indications, and it also show NDBs. The station actually can be set off. Then we have the waypoint. Waypoint actually is useful when you have low range selection, and it shows all the waypoints around your position. Then we have the airport. The airport actually show with circles the actual airports around you. In this case, we are at the Sierra Uniform Mike Uniform, as you can see. If I set this off, we can select on the data. The data actually show constraints on the route. Actually, we will have some waypoints around the route. If we select those waypoints and the data button, actually the data button will show us the constraints on any waypoint you will pass, and also we will show the estimated time of a route for any waypoint on the route. The position switch actually, if you turn on, show the position of the 3 IRS and GPS receivers. The IRS receivers are actually asterisk-like, and those triangles are actually the IRS, the GPS position. And actually, while flying, those moves around the airplane because the position of these sensors are actually different between one to each other, and actually you can see that one is slightly different in position respect to another. In this case, we have everything up because we are not moving, and we have aligned the IRS here. The last indication that is possible to turn on the navigation display is actually the terrain. The terrain is actually now in peak mode and show all the terrain you have around the airport. Actually, as you can see, we have the terrain indication here in blue and 2 numbers. These 2 numbers actually are for the peak mode only. The peak mode only show the lowest altitude on the range you are seeing and the highest altitude of the obstacle you are seeing. In this case, for example, we have the lowest obstacle is at 0 feet, while the highest obstacle is in flight level 9, that is actually 900 feet above ground level. Actually, I have also set the C indication in blue, and the green color are actually the same as I said on the VSD. So we have, as you can see here, in red, because now is the red indication is now red because it is more than 2,000 feet above us, and in fact it is at 5,400 feet. I can select terrain on, I can deselect down the range, and I can go back to my screens. Now I've said everything I can about the EFIS control panel, and I will show you other information. In case one of the display unit go to fail during the flight, the DU system actually works automatically to reselect the proper selection of display inside the airplane. Actually, if you maintain these 2 switches that actually control the display unit in normal position, those display will be reselected automatically in case of failure of any of the display unit. In case you want to have a better view of, for example, a secondary engine inside the navigation display, you can select it by rotating the main panel DUs switch. Actually, this rotate knob check also only those two screens, the PFD and the navigation display, while the lower DU check for the lower DU. Actually, if you select the engine paradigm, the outboard PFD, and you can select, as you can see, every configuration you need for your flight. Now I will go a little into the overhead to give you some information about other two switches that are actually very important to the flight. Okay, here we are. I want you to give some information about the display selectors. The display selectors actually works with source and control panel. For source, it means the display electronic unit actually working on each of the display unit. Actually, the switch is, the rotary knob is usually set on the auto position. If you select all on one, actually all the 6 display units will work with information given by display electronic unit 1, while selecting it all on 2 will actually works with display unit taking the information only from the display electronic unit 2. Actually, I will show you all on 1, for example, or all on 2, I will show you information. Later we have the control panel. Control panel actually works with the EFIS control panel. In the normal position, the left EFIS control panel works for the left DEU panels, for DEU displays, while both on 2 with the control panel will make the right EFIS to be able to control all the display information you have on there. If I select both on 1 in this case, and now I go back to the main panel, like here, as you can see we have both on 1, and I can open the PFD, and as you can see there is a yellow indication here of display source. Display source because actually is saying me that I'm using all the source, only one sources for all the display, and this make it possible for the airplane to cross-check informations immediately, like it does with 2 different DU units. Actually, if you, for example, select now range, as you can see, the EFIS control also the right navigation display, and this is also for modes or plan switch, as you can see. Now I get back to normal configuration. Actually, I set the source in auto and the control panel in normal, and so I have no more the display source indication. This actually is everything I can give you about the display system and the indication of the flight displays. Actually, I can show you some more information about the VOR, the EDF that I will set now for valid stations, and I will also show you about the standby instrument. Okay, here we are. I have just set a possible route inside the FMS to give you some insight about the navigation display information provided here. In this case, I will open the navigation display. You can see now we have much more information than before. I've set a route, and now I will give you some information. Actually, we have selected a valid VOR frequency on both sides. As you can see, it's Charlie Romeo. We have the DME displayed, and we have both pointers set in both sides. As you can see, I will select them off, and I will select first the one on. As you can see, it's a one line vector, and this pointed to the Sierra VOR. If I select the second, it will go up as a 2-line triangle to go in the direction of Sierra. Actually, I can also select the ADF pointer. The ADF pointer actually will point to the actual ADF and are at the same indication of the VOR1 but in blue, and I can select them off now to release some information from the screen. Actually, as you can see, we have 2 dashed green line that actually are the radial that we have selected for the actual VOR selection. I can rotate it, as you can see, from the core selector to any position I want. We have here a dashed white line that is actually the runway indication I selected, and the dashed is the center line of the runway along the route. Actually, you can see the magenta line is the actual route for the airplane, and this is the first waypoint of the route. Actually, it's CRR03. Actually, as you can see, now we have up here a valid waypoint that is actually a conditional waypoint for altitude, and this is 610 feet above ground level at the time that we will reach that waypoint and the distance to that waypoint. Actually, if I zoom out, you can see a full route will be shown, and now I will go to the plan mode to show you how the plan mode is better. The plan mode, as you can see, show only the route of the airplane. Now you can see the various waypoints along the route, the magenta line that is the route. Actually, there is also the indication about the actual top of climb and the actual top of descent for the arrival, and then there are all the information about the flight. If I zoom inside and then I go to the legs page on my FMS, there is a step. If I press the step, actually the plan mode will go to the next waypoint, selecting center here, and I go again to step, this here set, sorry, and I will select step again to EFIS, step again, and now we will go to actually the arrival. As you can see now, this is pretty much arrival. We have all the information given by the route, all the arrival runway with their center line. We have all the procedure displayed. I have selected actually if you are giving arrival, this is not so important. And the thing I want to show you is that the channel line is the actual missed approach route. Missed approach route will be not armed and not active until you press takeoff, go around, and after you actually do the go around or over the runway, this blue line will be magenta, and the missed approach route will be active. Now getting back to the maps page, I will go out, I will go back, and I will show a standby instrument. Now I will zoom out inside for standby instrument. Those standby instruments are actually the ISFD and the RMI. The RMI is pretty simple. There is magnetic indication with magnetic ring around and 2 pointers. You can select ADF or VOR selector for both the pointers to select the actual source of the pointer. The RMI is actually controlled by DC power, and the magnetic is given by the IRS left system. The ISFD is actually a digital instrument. You can control its luminosity by two switches here. It presents the speed, the altitude, the altitude, the barometric selection. Actually, you can select hectopascal or inches, and the reset button to reset. You can turn this knob to select other pressure, or you can press it to standard pressure. If you press approach, you can actually enter in approach mode, and approach deviation scale will be set on. You have back course selection or approach mode. Actually, you can select the one you need for. Now I'm zooming out because it's getting night. You can see the sky is pretty covered. Is sunset yet? I hope you have enjoyed this tutorial, as I given you any information I can, and I hope that there will be no other indication important that I left out. Actually, I left out some indication given on the PFD scales. Actually, if I zoom out in, you will see in flight that there will be actually red and black scales on the speed tape. Actually, those scales represent the minimum, the stall speed, and the maximum, the MMO speed for the actual configuration. Actually, those speed will move if you have actually the flaps down, the landing gear down, and it will be selected based on the actual configuration of the aircraft. Other than that, as you can see, there is no more an indication about landing altitude and about novice speed. We have a V1 indication here because we have set the V speeds, V1 133 set here, and actually this is the indication about the V speeds. Starting up the climb after the takeoff, you will see also in green here the flaps maneuvering speed. When you pass, actually, there will be an indication for each flap maneuvering speed, for flap retraction schedule, and also for information to your flight. Other information I left out, yes, this yellow line is the actual altitude of the ground, and this dash should see the altitude of the ground now. And actually, I think I've said everything I can actually say to you. The last information is about the configuration of those screens. Actually, we are watching into some PFD and D configuration. The 737 next generation actually had also another configuration. So it has again another configuration that is actually the EFIS map mode. The EFIS map mode anyway show less information than this. So with this information I give it you, actually you can actually understand also the EFIS map display. And the EFIS map display was done mainly because it was more similar to the 737 classic configuration with actual digital instrument displayed as analogic instruments, and this configuration will be used and are used today to make possible to pilots flying the 737 classic series aircraft to pass to the 737 next generation with less problems and less time into the type rating. Say that also one thing I left out is the actual flight mode annunciator and the flight director. The flight director can be set on by two switches. As you can see here, we have a flight director boxed indication here, and in green, and actually you will see two split bar in magenta for the flight director. Actually, this is not the only configuration for the PFD. There is also a mixed configuration that show a unique flight director giving you information about the configuration you want for the flight, and actually this is less used than the split axis. The main used configuration is PFD and D with split axis configuration. This completes our tutorial, our little overview about displays, systems, and DU units, and I hope you enjoyed actually the video. As you can see now is getting dark. I will go out and I will tell you a little more information about last things I left out. Actually, we are now out from the aircraft, as you can see. I hope you have enjoyed this video, this tutorial, and actually I will do the next tutorial as soon as possible, and it will be about autopilot. This is the reason I left out flight director and the autopilot information, because I will do a tutorial about flight director and autopilot usage and modes during the flight. Actually, probably I will do the autopilot video and then an FMS video about the configuration of the FMS. That is pretty complex for a newbie, so I expect it to be very long. About this, now the lights turn down because it's night, and actually I will do this as soon as possible when I have time to do this. This complete, as I have said, our second tutorial about Avgeek Life and display overview of the 737. The information I gave you here are actually very good for 737, and actually are some of the information about the general information display system for any aircraft. Actually, I think almost every Boeing aircraft and also the Airbus aircraft around works with similar systems and similar commonalities. I hope you enjoy the flight, sorry, the video, not the flight yet, and I hope to see you later in the next videos. If you have any question, if I left out anything, if I did any error in the video, excuse me, and write me down any comment if you have anything you want to see, you want to know, you want to be explained in the next video. Thank you very much, and from Paolo, a good bye-bye to the next video.